so the first category of sequences we're going to talk about is the arithmetic sequence and series. What an arithmetic sequence is it's a sequence in which the difference between successive terms is a constant, right? So for example, if you take two terms and subtract them, and then if you take two other terms and subtract them, and you take two other terms and subtract them, you're going to get the same difference. You're going to get the same value. That difference is called the common difference, and we call it D. Okay? Now, I know you're going to ask, what are you talking about? So let's just do this first one. Determine the common difference and find the next four terms of the arithmetic sequence. So to find the difference, the common difference, we do A2 minus A1. And order matters here. So not A1 minus A2. Okay, A2 minus A1. All right. So here, D is going to be, all right, so if this is A1 and A2, it's going to be A2 minus A1. So D is negative 36 plus 53, and that's equal to 17. So that's the common difference D. That means, like, if you go down the line to like term number 156 and 157, you subtract them, you're going to have a difference of 17. Okay? So now it says, okay, find the next, how many? The next four terms. So we say, okay, negative 19 plus 17 will be negative 2. And then negative 2 plus 17 will be 15, and so on and so forth. So the next four terms will be negative 2, 15, 32, 49. Okay, so the common difference is 17, but if you do this minus this, it's 17. But to go that way, the difference between them, so difference is what? Difference is how far apart the two numbers are. Okay? So if you subtract these two, you do get 17, right? So it's how far apart the numbers are. This minus 2 will be positive 17.
So then sometimes you'll have to go the other way. And sometimes you'll have to subtract if it's actually.
Well, the common difference, if the common difference was negative 17, then you would have done negative 19 plus negative 17. Okay? We don't think of it as subtracting, we think of it as adding a positive or a negative number. Okay. Okay, so if you have an arithmetic sequence, okay, then it's very easy to find the nth number, just any number. Like if you have this one and I ask you to find, okay, what's the 204th term? It's very easy to find it. Because, okay, so let's think about this for a minute. Suppose A1 is 5, okay, in a sequence. And suppose for this particular sequence, D is equal to 2, okay? Then what would A2 equal to? 5 plus 2, right? And A3 would be 5 plus 2 times 2, right? And then A4 would be 5 plus, how many times 2? 3 times 2. And then A5 would be 5 plus how many 2's? 4 times 2, right? So you keep adding plus 2, plus 2, plus 2, plus 2, plus 2. Or you could say, okay, I add 1 2, 2 2's, 3 2's, 4 2's. So now, can we come up with a conjecture? If I'm on the 5th term, how many 2's have I added? 4, 1 less, right? So if I was on the 10th term, how many 2's would I have added? 9. You add 1 less. So then can we come up with this? So basically, A5 is equal to, this was A1, okay, plus n minus 1 times 2. Does that make sense?
Yeah.
Okay. So Well, how did we get this? It's A1, what we started with, plus whatever number we're on, 1 less times the D. Okay? So that means my formula for it is this. A1 plus n minus 1 times D. That's AN. Okay? All right. So let's do example number 2. It says find an explicit and a recursive formula for the nth term of the arithmetic sequence, blah, blah, blah. Okay. So if this is the arithmetic sequence, what is D? And that's negative 11. And what is A1? It's 14. Now, the general formula is AN is equal to A1 plus n minus 1 times D. Now, let's put in the specifics for this problem, for this sequence. AN is equal to 14 plus n minus 1 times negative 11. Does that make sense? Now, can we simplify? Of course we can, because we're in Precalc Honors. So AN is 14 plus, well, minus 11n plus 11. So AN is negative 11n plus 25. This is the explicit formula. Okay? Okay. Now, how about the recursive formula? Remember, for the recursive, we specify one term, like A1, and then we say every other one is, like plus 2 or plus 3 or whatever. So we have to specify what is A1, and then I have to say, for a random term, you take the one that comes right before it, an minus 1. Okay? I'm writing it now. So it's where you generate numbers based on like the one that comes right before it. So you take the one right before and you do something. So you start with, so this is some general term. This is the term before. And for this sequence, what do we add to each term to get the next one? What's D for this one? Negative 11. So for each one, we're going to add negative 11 or subtract 11. Okay? So how much is A1 for this? 14. And then you say AN is AN minus 1 minus 11. That's the recursive one. Okay. First term of the arithmetic sequence, so we want to find A of 41. So A41 is equal to A1 plus n minus 1 times D. Okay, what is A1 for this problem? 11, and D is 4 minus 11, negative 7. So the 41st term is 11 plus, okay, n minus 1, that's 41 minus 1 times negative 7. Okay, and that is apparently 269. Negative 269.
When D is a negative number, does it turn out to be a negative number?
Well, eventually, yeah, because when D is negative, you're adding negative numbers, which means you're subtracting. Okay, now this one is another just plug and chug one. Now we want to find the first term, meaning now we want to know what A1 is. And we're given A44, so this is AN, right? And what is N? 44. So n is 44. AN is 229 and D is 8. And we're going to plug it in the same formula. A44 is equal to A1 plus N minus 1D. So 229 is equal to A1 plus 43 times 8. And I solve for A1 and it's negative 115. Okay, almost like too boring, right? Yeah. Okay, now how about arithmetic means? What are they? A mean is an average, okay? Arithmetic means are terms between two non-consecutive terms in an arithmetic sequence. Oh my gosh, what does that mean? Okay, so what does it mean, two non-consecutive terms? Well, in a sequence, right? If you have a sequence, the ones that come right after one another, those are consecutive terms, right? The ones that are next to each other. So two non-consecutive means two numbers that are not sitting next to each other. So, for example, look at the 7 and the 47. Those are two non-consecutive terms. The numbers that happen to lie in between them, those are the arithmetic means between 7 and 47. Okay? Yes? So, if I had another sequence, 1, 3, 5, 7, 9, 11, is this an arithmetic sequence? Yeah, because you're adding the same each time. So suppose I pick two random non-consecutive numbers, 9 and 15. What are the arithmetic means between 9 and... There you go. Okay? So now it says, write an arithmetic sequence which has 5 arithmetic means between 6.2 and negative 1.6. Okay, what does that mean? That means between 6.2 and negative 1.6, there have to be 5 numbers. Ooh, I made that fit just perfectly. Okay? No, because it's a sequence that's going down as opposed to going up.
Yeah.
Well, no, not necessarily. It doesn't always have to go in increasing order. Okay? You go in the order that it's presented to you. Okay, so here's what we're going to do. A1 is 6.2. So basically what I want is to figure out what D is. AN is negative 1.6 here. Now, how many total numbers do I have? 7. N is equal to 7. And you want to find what D is. And yeah, there are like lots of different ways to do it. Because there are seven total numbers now. Right? 1, 2, 3, 4, 5, 6, 7. Okay? Okay, so if AN is equal to A1 plus N minus 1 times D, negative 1.6 is equal to 6.2 plus 7 minus 1 times D. So D is negative 1.3. Yes, and then you're just going to add, okay? So you're going to do negative 1.3, and you're going to get 4.9. Negative 1.3, and get 3.6. And then get 2.3, and then get 1. And then negative 0.3. And look, if you add negative 1.3 again, you get negative 1.6. Oh my gosh, how incredibly awesome. Yeah? Okay. And yes, there are, like, you can... I know many of you could just look at this and go, oh yeah, you just subtract the first and the last and you divide by 6 because that's how many divisions. That's exactly what we're doing because that's how basic, like that's how common sense the original formula was anyway, right? When we all...
Wait, why 6, not 7?
Because there are 6 divisions. After this, there are 6 divisions. So if you divide this, and that's what we did here, look, we subtract and then you... So let's talk about arithmetic series, okay? Remember arithmetic series are, you just take the sequence and now you're going to add all of the terms, okay? And the derivation is really pretty cool, but I'm going to move on to the first example. So the formulas for derivations, for the sum of a finite arithmetic series are this. Sn, okay, is n over 2 a1 plus an. And you have a second formula. They are literally the same thing, but you just use them based on what information you've got given to you, okay? So the first one here, what I have is the sequence here. And we're gonna use formula 1 because do we know what D is in this one? Can we find D here? It's 2 minus negative 3, that's equal to 5. Okay, how much is A1? A1 is negative 3. AN is 157. Okay. Now, can we find how much N is? Well, let's use our handy dandy formula for AN. A1 plus N minus 1 times D. So 157 is equal to negative 3 plus 4 times, N minus 1 times 5. Okay, solving this is pretty much algebra, so I'm going to just tell you N equals 33. Okay, so let's use formula 1 because it's simpler. Sn is equal to n over 2 a1 plus an. So S33 is equal to 33 over 2, negative 3 plus 157. So Sn, or S33 rather, is 2,541. Okay? All right, so it's mostly just plugging it in. Okay, so here, let's find the 17th partial sum. So that means I want S of 17, yeah.
So what we just found, S of 33, that's if you add negative 3 plus 2 plus 7 plus 12 all the way to 157. You add all those, you get 2,700.
Wait, what is 2 equals 3 equals 5?
It's an S. What? 2 minus negative 3 equals 5. Okay. So, all right, so here's the series. This is A1. I can get I can get D, but I don't know what AN is, right? So, A1 is 53. D is 31 minus 53, 17, and negative 17. And I don't know what AN is, so I'm going to use formula 2.
Isn't 31 minus 53 negative 22?
Oh, is it negative 22? Oh, yes, sorry, I looked at the wrong line. Negative 22. Okay, so formula 2 is Sn equal to n over 2, 2a1 plus n minus 1 times d. So this is equal to, n is 17 over 2, 2 times 50, n is 17 because it's S of 17, right? 2 times 53 plus 16 times d. So that will be Negative 2,091. Okay. Okay. This one. Do I know what A1 is? A1 is when n equals 1. So what's A1? Well, okay, so let's take a look at this one. Where does it start from actually? I missed that one. Where does it starts when n equals 10. So what's the first term? First term is 16. Okay? What's the next term? 17. Right? That's when it's n equals 11, so it's 17. Okay? So how much is D then? D is just 1 because we're going up by ones. Okay? Now, how much is n? N is the number of terms we have, and this is where people always get stumped. If you start at 10 and go up to 32, how many is that? Is it 22 or 23? It's 23. So if you start counting 10, you have to include the 10. So 10, 11, 12, 13, 14, 15, all the way up to 32, that's 23 of them, okay? So it's 32 minus 10 plus 1. Okay, and think about it, like count up and you'll see why it's true. So now, what's AN? That's A of 23, which is 32 plus 6, 38. Right, we needed all this to find the sum, okay? And that's the last number. The last number is when n equals 32, right? So it's A of 32. Oh, sorry. It's A of 23. Okay, so. Huh? No. Okay. How many numbers are there in the series? There are 23. The first one is A1. The last one is A23.
But it's still n counts as.
It still counts as N32. So maybe it's less confusing if I wrote it like this. A of 32 because it's the last term. Okay. There are 23 terms. There are 23 terms. It starts at 10 and goes to 32. Okay? So the first one is A10, the last one is A32. Okay. So we're going to use Formula 1. SN. It really doesn't matter. It's 23 would be more correct. So it's so yeah, so this is 23 over 2. What's A1? 16. The first term is 16 and the last one is 38. And that gives you 621. Okay? So this is the homework for tomorrow. If there is one on for Monday, if there is one on second differences, you can skip only that one.